Hello, and welcome to 5 Minute Math. Today we are looking at the 7th grade concept of volume. This is standard 7.9a in the great state of Texas, and we are using item number 5 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got a chocolate bar and the shape of this triangular prism, and we need to find the volume. All right, so let's look at our reference materials and see what we have here. We've got linear equations, circumference, area. All right, volume. So prism or pyramid. Now, we need to be able to recognize that this is a triangular prism. They do give that name to us right here in the actual problem, but if not, we need to know that a prism is a three-dimensional shape that's got two bases that are identical polygons, like two triangles, two rectangles, two hexagons, whatever. And it's simply going to be base times height, okay? So V equals base times height. Now this big B, this is going to be the hard one. This is going to be the base, the area of the base, and it's going to be the face, the face that gives this the name. So this is a triangular prism. So in this case, we're looking at the triangular base. If it's a hexagonal prism, we're going to look for the hexagon. If it's a rectangular prism, we're looking for the rectangle. All right, so we're looking for this right here. So here's our triangle. All right, so we need to find the area of the base, and then we need to find the height. Now, the height can also be confusing because when we're looking at the base, that is what it would normally sit on, and the height is going to connect the two bases. Well, where's the other base? The other base is back here. I don't necessarily show it, so it's going to be like right here. And we've got these lines kind of connecting the two, right? So here's my other base back here, my other triangle. And so what is connecting these two bases? Well, it's not sitting on its base. It's actually sitting on one of its sides here. This is the connecting line right here. So that means this is my height. Whatever face or whatever distance separates the two bases, finding the base, look at the name of the prism, that's the height. So this height is going to be 20 centimeters. Now we need to find the area of that triangle, in case you need it. Let's look at our reference materials. Let's go back up. Area of the triangle is going to be, let's go ahead and say A of the T is going to be 1/2 base times height, but it's little b, okay, because the big B is the area of that big base. So now we've got a different base we have to look at. So it's 1/2. Here's my triangle. The base is the distance across the bottom, okay? So just pick one side as the bottom. Here we go. So they give it to us as 10. And then the height is going to be sometimes a side, but that's only if it's a right triangle. If it's not a right triangle, they're going to give you a dotted line. They're going to have to show you the distance that's perpendicular to the base between the base and the highest point. In this case, it's going to be this 12. So typically it's that dotted line. You know it's the height because it's got that right angle. It has to be perpendicular to the base. So that's going to be a 12. All right, so let's multiply this. I can do 1/2 times 10, that's 5, times 12, so that's 60. 60, at this point, we're at square centimeters. And so that's the area of the base. And so I can replace this V equals 60 square centimeters, because I did that separately, by this 20 centimeters. All right, so we can just use our properties of multiplying by multiples of 10. 6 times 2 is going to be 12. And then it's an extra 10 for each, so really it's an extra 100. So it's going to be 1200. And then at this point, we are now at cubic centimeters. This is unnecessary. That 13 is extra information. That's slant height. Don't need it. Our answer is D.